Thank you, thank you, thank you. First of all, shout out to the folks fixing this. This is being held by duct tape and hopes and dreams. So I will try to type lightly. But if anything happens, it's going to be funny, if anything. So friends, welcome to a code talk to compiling blazing fast MCP servers with Rust. My name is Darko, and today I will be showing you things I've built, how I built them with Rust, with some MCP servers. I even have a receipt printer here that I may be using an MCP server to print receipts. What? So for the next hour or so, we're going to be just looking at some code, discussing stuff. I'm going to kind of live code-ish show you some stuff, but this is an open discussion, so feel free to ask me questions, point out where I'm wrong, and troubleshoot with me. I only have, I think, like 2 important slides. Everything else is code. So we're going to be looking at that. Before we kick it off, my name is Darko. I come from a long line of system administrators. That used to be my job, fixing AIX stuff, Solaris stuff, Unix, Windows 2003 and 2000. Then these days I go by developer advocate. That means I code, I talk to developers, I build, I make sure that AWS builds stuff that you care about. I'm heavily involved inside of the Rust thing when it comes to AWS, and I'm a big proponent of Rust. I've actually started coding Rust like 3 years ago, attempted to learn it a couple of times, realized there's something called a borrow checker, and I just gave up. Then I realized there were lifetimes, I gave up. And then third time I plowed through it all. So I have this big Rust learning journey that I've been doing for the last few years, and I want to take you along on some of the things I've learned. So before we start, how many people here use Rust? Lots of great beards. I see the beards grow and everything. I get it. It comes with the territory. Not enough IBM ThinkPads. I'm surprised. Everybody's MacBook here. I thought like it was mandatory. My work laptop is a MacBook, but the laptop I write Rust on is a ThinkPad. So good to hear. Anybody here uses MCP servers? Okay. Anybody wrote an MCP server? It's usually more people writing MCP servers than using MCP servers. I get it. But that seems to be the story of the day. So okay, let's kick it off. First of all, I want to talk quickly about MCP, because while I understand that most of you use it, some of you have written it, I just want to explain what an MCP server is. An MCP server is MCP is an open protocol that allows an LLM, a coding assistant, a chat application, something that uses generative AI to interact with tools, resources, and prompts on your computers. When tool use became a thing a couple of years ago, you had to write an application and kind of expose tool invocations to your LLM, so it would basically run commands on your behalf in an arbitrary programming language. And then the folks over at Anthropic and a few other places decided to make an open protocol called MCP. And MCP is just a way to basically provide these tools to your LLM no matter what they are. No matter what the client is, you can use MCP, as long as the client supports it, to provide it with additional functionality. And I'll give you an example of an MCP that I've built for myself. I built something called, I'll share the link later on, but I call it a Grimoire MCP server. I found that when I code in Rust, I have this need to I make a cool little code pattern. I built something that works really well. I'm like, oh, that's just perfect. I want to keep this. I want to save this. I built an MCP server that would basically, I will tell it, oh, by the way, this function, store that as a code pattern. So what my MCP server does, it goes ahead and it saves that code snippet in a markdown file somewhere on my file system. An LLM by itself can't do that. An LLM by itself can't interact with your file system. But LLM by itself can't do search the file system or write or read stuff. You have to give it tools to do that. And MCP is the best way to do it. Now, there are a plethora of MCP servers, both good and bad. from web search MCP servers to documentation MCP servers to even MCP servers that let you to like query a database or whatnot. So people have been building MCP servers since they came out, but most people build them in Python. Boo, Python. By the way, lukewarm take. Python needs to die. Hear me out. With the world of LLMs, with coding assistants, with everything at your fingertips, you don't need to write Python anymore. You can write Rust, you can write Java, you can write TypeScript if you want. A more safe, more secure, compilable language. Since it's no longer hard to write Rust, with a coding assistant, it's so easy. So I keep telling all my friends, stop writing Python. And they keep telling me, why are you telling us that? It's a dinner. So it's, Python needs to die. Yes, so a lot of the MCPs you will see out there are built either in TypeScript, JavaScript, or in Python. The problem with that is, does anybody know how you install an MCP server that's a Python or TypeScript? How? Painfully. It usually involves a npx command or a pipx or uvx. Basically, you're pointing it to the internet and hoping that what you get back is the correct thing. Every time you start your coding assistant, it goes to the internet, gets the latest version, downloads it locally, and runs it. And that usually, well, let me show you. That usually involves my segue to why Rust. Well, this is why Rust. That thing on the top and that thing in the middle are Rust MCP servers. The AWS API is TypeScript. That's a lot more seconds, or a second more than the rest. It takes a longer time. And I spin up my coding assistants as fast as I can, and when I have to wait 4 seconds for a thing to load, I don't like that. And I found a way of having a MCP server just pulled from the internet as I work on it, not really fun, right? I feel like we haven't figured it out how to do it properly yet. But with Rust, it's a binary. It's a compiled binary sitting in your path. That's it. When you configure your mcp.json, whether it's in Kiro or Cursor or Cloud Code or whatever you want, it's a binary sitting on your file system. Yes?
You're only mentioning MCP as a local server, and it can and should be remote. So I hope that you talk about it as well.
Yes, so I'm currently talking about local MCP servers, right? Remote MCP servers are starting to kick off. Not every client would support a remote MCP server because the S in MCP stands for security, right? But you can, with the Rust SDK, you can build remote MCP servers. I am a fan of local MCP servers working over stdio because especially if an MCP server needs to work in a local file system, something locally on my computer, I'm okay with that. But remote MCP servers.
Limiting it only for developers instead
Yeah.
of opening it up for everybody.
Correct. Yes, so the thing is, I think the industry as a whole hasn't figured out how to properly distribute MCP servers. And you will see that everybody has their own like npx or pipx or uvx or cargo install and then just hope for the best. We need to find a way to have a marketplace for MCP servers. Like ideally that you can just point it to the internet and have it like a remote MCP server, or if it's a local, just something that installs locally and just works. So let's build an MCP server. And I'm gonna show you how this works and how this looks like in Rust in a second. So I need to do a little bit of a dance here with my 2 things. So here's what we're gonna be doing. I have a little to-do API. It's a JSON API running on my laptop. You can imagine this running somewhere remotely, but in this case, it's a to-do API running on my laptop. It's as simple as it gets. It's a CRUD thing that I can create, read, and list to-dos. I can archive them, I can complete them, whatever, but these are the things they do. I have a printer. I have a little receipt printer here. So my MCP, the MCP we're gonna be looking at today, is gonna go ahead and be able to create new to-dos get all to-dos and print a to-do. How many times will I say to-do? So this is what we're going to be looking at today, and I'm going to take you through different steps of creating it with Rust, and I'm going to explain different elements of a Rust MCP server as we go. Okay, so let me get to it. Right, that's not it. Stop presentation. And show. There we go. All right. You all can see this. So I have the repo with the full code ready, but I've split it up into 4 stages of code, so I don't have to just manually type it out. But I will be going over little bits of code as we talk to it. So I will make this code available to you later on. I do have a MCP server that's kind of like public already, and you can access it if you want. This is more of a joke MCP server and doesn't really work without my to-do app and the printer I have here, but you can take inspirations from it. Also, we just launched an IAM MCP server, IAM policy autopilot MCP server. It's basically an MCP server that helps you generate really good IAM policies based off of your code. It's a Rust application, it's a Rust MCP that looks at your code, and based off the code, it generates your policies deterministically, which is shenanigans. So I'm gonna go into the first one here, and let's look at the directory structure. First off, the most important thing you need to understand is we are using the Rust SDK for MCP, or RMCP. Up until a few months ago, it wasn't even listed on the SDK section of this page, so they didn't even show Rust as the SDK, so it wasn't ready yet. I remember like a couple of months ago when I was doing it, it was still a version 0.1 point something, and currently it is a version 0.10, apparently, since 3 days ago. So it's a fast evolving MCP server, but it does support everything that other MCP servers support. It's up to the latest standards of MCP servers. So we're gonna be using this, and what's great about RMCP is that it comes with basically 2 elements to this crate. It comes with RMCP. By the way, I'm gonna throw some Rust lingo here. So if you don't understand what I'm saying when it comes to Rust, just let me know, I'll explain. I'll try to keep it very obvious what I talk about. A crate is a library for Rust. It's a package we get from the internet that's part of the, just your Rust application. So it comes with 2 crates, RMCP, the core crate specifically, and the RMCP macros. This is the thing that actually helps you create tools and tool handlers and routers and all those things that are important for an MCP server. Let's get started with this thing. So in my application, in my source file, I actually have 2 files. Now, you don't have to have it this way, but there's a main file. This is the entry point to my application, and I have a to-do file. This is where I keep my tools and my tool router and all those things. I'll start with the to-dos, because that is where the important things are happening. So this one is a little bit cleaner here, but I'm gonna explain the couple of critical elements when it comes to defining an MCP server in Rust. Number 1, you need a struct for an MCP server. This is the struct that has to contain something called a tool router. And a tool router is basically just a thing that, well, routes tools to your MCP client. This is an important, and this specific struct must contain the tool router, object or element or property, right? And this is an important thing. Without this, there is no tool router. So defining a struct called whatever, you can call it with this whatever. To do MCP server is my name, but it can be whatever. And then you create an implementation block for tool MCP server with the macro. So this is where this thing becomes a tool router. By adding the tool router macro here, basically what you can see here, it generates a tool router based on functions marked with the tool. And I'll show you how those functions look like in a bit, because we don't have them in this version yet. So you define a macro, you actually decorate, is that the word? Decorate an implementation block with the tool router macro, and all of a sudden, everything that's here becomes tools. Except for the first one. new method implementation that will basically just create a new tool router with a tool router element in the struct. So simple just generator function, nothing special. Then, for the same, we need to implement server handler. So the server handler is the thing that basically tells the specific struct that it is a MCP server in this case. So we need to implement the server handler, and we need to decorate it with a tool handler macro. Again, this tool handler macro will just generate the handler for tool calls and list tools, all of these specific methods a tool handler needs to be able to work as part of a MCP server. And you can see the documentation is actually pretty good because it expands to basically a call tool and list tools requirements. These are required functions for any server handler according to the MCP spec. So, and luckily this macro does it all for us. You have to provide a function called getInfo. GetInfo is a required function. This will actually prompt you, if you have an LSP, it will prompt you that this function must exist. The getInfo function basically returns to your MCP server, tells it, hey, listen, to your MCP client, hey, here's who I am, this is my protocol version, these are my capabilities, this is my specific implementation, and here are some instructions that I give along with the with the introduction. So this is where your instructions go like, hey, I manage a list of to-dos that are stored behind an API server, these are available actions. This is where you go like and create a big old system prompt if you have a specific thing to your MCP tool. Lastly, you need an initialization function. Basically, this is initializing the server handler. And all of that is being used inside of the main file. And you can see here, basically, we are just creating a service, and that's it. Now, it says it's a service. Now, this is not it's an STDIO MCP server. So there's multiple types of transports when it comes to MCP. One of them is STDIO. That means it works through standard input-output, basically locally. Other ones are you can do remote stuff using HTTPS and stuff like that. In this case, I'm serving it exclusively through STDIO, and that's it. So this starts, that's the entry point, and it just waits. Let's see if this works. It's gonna be fun if it doesn't work, right? So I want to show you something more. So just a fellow developer. Anybody here using make? A couple of you? Just? Okay. Task files? Okay. For you that don't know, this is a just file. Just file is very similar to make, but way easier. If you have ever written make, oh my God. By the way, did you know make is 40 years old? I think it's even older than 40. It's insanely old. Like it was built back in the day so you can speed up your build processes so it will be way faster. In any case, if you're using make, try just, it's gonna be way easier. So in the just thing, I have a they call it not formula, I forgot what they call it. I have a command called MCP test, and if I do just MCP test, it's gonna compile my application, and it's gonna run the MCP inspector. For all of you developers of MCP, MCP inspector is your friend. It's a tool built by the MCP folks. It's basically a TypeScript tool that's gonna run locally, but spin up inside of your browser. And this is where you're gonna be doing all kinds of things like connecting to your MCP server. Let me close other tabs, like that. Connect. And that's it. I'm connected to my MCP server. My MCP server is running, and you can see here like there's some initialization messages. It lists all the tools. It gives me this instruction set, which is just the thing we passed it, and that's it. If I call the list tools command, I get nothing because we have no tools, right? But the MCP server works. And I can literally now hook this up to a client and just, it will work. Like, it will work. But there's nothing to it. So we need to move on and add stuff to it. So let's do that. I'm gonna close this. Actually, I'm gonna close this. And we're gonna move on to step 2. I'm gonna pause here for a second. Any questions, comments about the general overlay of an empty MCP server in Rust. Excellent. We're not done. There's more. Oh my God, I wish. So let's move on. Let's move on to the second version. This is a second commit I have with a little bit more code and a little bit more stuff. This is where it comes, this is where the non-boring stuff comes in. This is where it comes to you actually building the functionality of your MCP server. There are some MCP specific things that you need to know about, but most of it, it's just Rust. But let's talk about it. I have a couple of additional structs here. I have two additional structs. These have nothing to do with the MCP server for now, but they're structs for my to-do, right? In this case, I have an individual to-do struct. Basically, it's the information I get back from my API. I get an ID, I get a user ID, I get a date, a title, body, all of these things. This is the information I get back from my API server. I also have a struct of to-dos. Very important. Due to the synchronous nature of MCP servers, this data, the whole collection of to-dos, always needs to be in an arc, or an atomic resource counter. Because each call runs in its own little scope. So if you run it once, and you get the list of all of your to-dos, and then you ask it again, what are my to-dos, it may not know what they are, right? It keeps it only in the context. If you clean the context, it doesn't know. So you need to be able to, you need to put it in an arc. Otherwise, you're gonna get this weird behavior where it doesn't really act properly, and it's like, oh, I'm sorry, I don't know what you're talking about, stuff. So the main struct that you're returning back to your, like a collection of things, if you're, in this case, collection of to-dos, need to be in an arc. And all of the examples out there from the Rust SDK use an arc. So atomic resource counter. Now, this is where we implement functionality. Now, this is not a tool. It's a function. It's a function called getToDos. And this is where it gets a little bit weird, right? Because I have a function that just uses request, request library, to request something from localhost, gets it back into JSON, stores it in this big arc, and returns it to me. Again, pure Rust, nothing special, just does that. But these are not tools. These are functions that our tools are gonna call. And the tools are also functions, so it's kind of weird. You could technically do this in a tool itself, but I like to separate my concerns from individual tools. And I'll show you why. So that's a function that gets all of my to-dos. This is a tool that gets all my to-dos. As you can see here, the difference is, this thing is not directly making the call to my API. This is calling the function getToDos. And then, of course, what we're doing here is we're doing the following. There is a macro here, the tool macro. This basically describes what your tool does. You can give it a description, you can give it a name. If you don't give it a name, the name of the tool will be the function name. But you can also name it whatever you want. So in this case, we're basically decorating this function to be a tool. And we are telling it that the result is gonna be a called tool result. And the error is gonna be something called an MCP error. Now, an MCP error is an alias to error data, but I use it as an MCP error here. You can use error data if you want, but because I started a long time ago, they used MCP error back then, I just keep it the alias like this. It is important to use the call tool result, because that basically tells the MCP server what is the result of a tool call, that specific type. So we're calling all the to-dos. We are basically, because it's an asynchronous function, it's doing an await, and then we're just mapping an error. If there's a problem, I'm using MCP error here as an internal error saying something's wrong, and that is being returned back to the MCP server. Didn't work. If it did work, what I do here is I convert it all into JSON. I convert it all into JSON, and if it didn't work, of course, I fail out. I do a map error here. Bye. And then lastly, here's the MCP part of it. The call tool result. I'm sending a success if we made it, and your response, the success always need to be a vector of something. So the success here is basically a vector of content. In this example, content is just JSON, but content can also be text, whatever, right? There's different types of content you can use. In this case, content is JSON, but it needs to be a vector of content, even though it's a single element in this case. So what happens here is basically, if this tool request is successful, we just respond. That's it. Nothing else needs to be changed from the MCP server. The only thing I've done here is I've added a line to the instructions, just telling the MCP server MCP client, here are the tools I support. You don't have to do this necessarily because that's kind of being presented as part of the capabilities. But yeah, this is a thing I like to do. So let's try. So if I go ahead and do just MCP test, yes. Compile. Is it compiling from scratch? No, okay. Back to the MCP inspector. We're good. Connect. We're connected. Excellent. So look at the initialization here. We have it doesn't list any tools. I don't know why this doesn't do it that way. But it lists all of these things. If I do a list tools, we get a get all to-dos tool here. All of a sudden, we have the ability to run this specific tool. And let's try it. Boom. Success. And there it is. It listed. Now, this output here is literally just a list of all the tools from my API server. Doesn't really matter, but the tool has been successful. So the MCP inspector is the first thing you should definitely look at when you're building stuff because it helps you troubleshoot a lot. You get a lot of server notifications here. You actually get the specific messages getting back here. You can see that it's from stdio, and it's just a great way for you to troubleshoot these things. Okay. So that is tool number one. And this is the simplest tool. There's no parameter. Go ahead, sir. Can you speak up slightly? Sorry.
Does the MCP inspector automatically come with the RMCP, or do we have to write some code for getting the UI?
Oh, you mean the MCP inspector? Yeah, it supports it out of the box. So because MCP is an open protocol, so the question was, do we need to do something specific with the MCP inspector so it supports our MCP? No, since MCP is an open protocol.
I think his question was, how do we get this UI?
Oh, easy. Let me show you. That's the command. I know I egged on NPX, but NPX, I know, right? That's how they provide it. Model context protocol status inspector, and then just pointing at your binary. That's it. So what it does, it starts up the inspector, the UI, and just adds your binary to it as the MCP server. Okay, thank you. Thank you for the clarification. Okay, we are good. Let's move on to take number 3, or take number 2. And let's look at stuff here. Go for it.
Did you publish this in GitHub? Can we look at the code?
Not of this one. I'll show you a different one I have, if you want. I have a different one that I can show you. Actually, let me do that immediately because it has the same elements to it, but it doesn't just, the only thing is it's just working on a local file system instead of an API server. So I can show you that one if you want. Actually, I'll show it to you at the end, so just bear with me. Okay, so here, let's talk about number 2 and back to the to-dos. So we have something additional here. This is, the example you've seen first is very simple. It's, there's no parameters. We're just calling a tool, that's it, right? Call tool, get all to-dos, done. Get some result, be happy with it. The next one is a little bit more involved. And you will see a couple of things here. This one creates new to-dos. And I have a couple of new stuff. I have another struct called the new to-do struct. It's just nothing to do with MCP server. That's how I pass a new to-do and actually go ahead and generate a new to-do. It doesn't matter. But the one underneath is the parameter struct. This is the beauty about Rust. Parameterized, type-safe parameters instead of just anything and everything into your MCP server. That's a schema, that's a struct that's being passed on to a tool in order to create a new to-do. I'll show you what this means. We're using schemas here because that's what you need to use for this specifically. You need to use a specific JSON schema for this to work. And I did find some bugs with this. I did find that certain coding assistants, and I haven't troubleshooted it yet, but I need to figure out what the problem is. Certain coding assistants don't like this. Well, it's not them. They're okay, but they pass some weird JSON schema back. It looks perfectly fine, but my MCP server says, look, not the correct JSON schema. I don't know what's going on. I need to figure that one out.
Maybe the schema version.
Maybe the schema version, but it's like 2020 something. It's like an old.
I think JSON schema supports 2020.
Yeah, I don't know which one it is, but it is 2020. I can show it to you later on in Kiro. Kiro, the IDE complains. For some reason it complains. I actually spoke to the Kiro team yesterday, and we need to troubleshoot it. It's my fault, but something to do with my JSON schema here. But it needs to use this in order to be able to pass parameters. 6 months ago, this didn't exist. 6 months ago, you can just pass it whatever structs you want. It didn't really care about the JSON schema. Now it cares. So here's the new function. This function, again, like before, it's just a function, part of the to-do struct. Doesn't really matter. It's not a tool call, but this is just me making a request, a curl call over to my to-do server, to-do API, and it just works. You may notice I hard code my URLs, as you all should do, right? No, I mean, it's just a demo, but you should not hard code URLs. Those should be environment variables, and I'll show you how to work with environment variables in a bit. So this function just basically sends over a JSON new to-do struct over to my API server that creates this specific to-do item, and that's it. Back in the to-do router, we have a new function here. And this function has additional stuff. It has parameters. Parameters specifically of the new to-do parameters type. Basically, we're passing these specific parameters as MCP tool called parameters. And then ultimately what we're doing here is getting a couple of information from the environment. In this case, I'm getting the user ID from the environment. That's not likely something you should be doing. You should not get user IDs from the environment. Maybe an API key from the environment or something sort of locally. But in this case, for me to be able to work with this, I'm passing on the user ID, just storing it locally, but you just use your standard Rust std env variables, that's it. Passing this, creating a new to-do request, calling the function we just saw, the create to-do, and then ultimately I'm returning a message back. As you can see here, the message, unlike the previous one, is not JSON. It's literally just text. Just saying it's a format macro, a new to-do entry has been created, here are its details, use the ID of the to-do for any to-do specific instructions. That's it, right? And I did this because I want my MCP client to know what has happened. Because each to-do item has a unique ID that's generated on the MCP, on the API side. So when I make a call to my API, it returns back to-do successfully created, here's its ID. I return that data back to the MCP server, so it can give it back to the LLM, so the LLM knows that it can do something with that ID, and it doesn't have to go and get all of them again. And you can see here that we're returning something called text instead of JSON, and that's it. Yes?
Okay, you could have returned JSON.
I could have returned, yeah, exactly. It's just, I can show you that it's not just JSON. I could have literally just returned the response from the server. I do want to encourage all of you, when building MCP servers, do not just blob JSON back. I spoke from somebody from Microsoft, and they had like an internal MCP server that would just return like kilobytes of JSON, right? Unnecessary JSON. And what happens? Context goes, right, full up. So return the data that you need. Maybe a little bit of instructions with your data. So this helps the LLM at the other side get the correct stuff. So So sometimes JSON is fine, but sometimes you may want to structure it a little bit better. Because like I don't need additional information. Like for example, I have the body, title, and date, but like I don't care about is it archived, is it completed, some other tags. It doesn't matter in this case because we just created it. So understanding what goes in and what goes back is pretty important. Okay, back to the MCP thingy. Let's try just MCP test and see what happens. I think we're going to be able to create a little MCP, a little to-do item here. So connect, list tools. Look at that, there's another tool. Click on this, and we have certain elements of this thing. The requirements based on the parameter are body and title. So the body is going to be share the QR code to this repo at the end. If I can type. DEV405, MCP with Rust. Okay. If I run the tool, boom, success. That's the response. See, a new, is that blurry? That's a little bit blurry. A new to-do entry has been created. Here it's details, all of those things. And that thing is actually now inside of my API server. Simple as that. As you can see, standard stuff, messages, all these things go fine. Look at the tool call. That's the tool call, arguments, and the title. Simple as that. It works. We're able to pass on information onto the MCP server, no problem. Let's move on. And it's not all about making API calls. It's not all about contacting a server. It can do whatever you want. Remember, it's a tool, in this case, because it's of its SDDO nature, it's a tool that can interact with anything on my computer or anything my computer can touch. In my case, I have a network printer here. And my network printer can print. So I'm going to move on to 0.3 and look at basically the final version of this. I'll explain the printer in a second. So here we have more things. This looks exactly the same. Struct is fine. But we have a new parameter here. As you can see, this parameter, it's called print to-do parameters. Same as before, it's a parameter struct that uses the JSON schema, and the only thing we're passing in is the to-do ID. That's it. The to-do ID to the MCP server that, well, just prints a thing. The way we do a print here is we are doing a little bit of a dance here. We are not querying the API server itself. We are actually getting all of the to-dos, and we are printing the to-do specifically, right? So what we are doing here is we are taking all the to-dos, we are iterating over them for a specific to-do ID, and then if it exists, we get the printer information and print whatever we want with the information, right? So we get the information from the task, like we get all of the things from from all the to-dos, and then we basically send that data on to print. And the printer here is, again, vastly simple. I'm using a specific crate called Recibo. There's multiple crates for Rust and thermal printers, Recip printers. Recibo seems to be the most stable one I've tried. There's a few of them. Some of them support network printers, some of them only USB. This one supports both network and USB. I did have some issues with the USB one because of Linux, I think. But this is it. Get printer config is just basically getting the configuration items, the IP address, the port, getting the printer. This is where you basically set up the printer driver. This is the Recibo thing. I'm setting up a network driver, opening up a specific IP and port. That's why I have a little wireless router here on my desk. Not sure if you can see it, but I have to bring my own network setup here. And I'm just opening up the printer, returning the printer itself over to the next function called print task. Now, this is an ugly function. And it's not me, it's the crate. Because the way you print on receipt printers is that. it's kind of a weird builder pattern, right? Where you just kind of add stuff to it, like initialize, alignment center, add some text, reset text size, feed 2, add two more lines, text size, increase text size, write text, reset text size to something else, give a line break. Unfortunately, this is how it works, but I made it work. I made it look like the way I want it to look. So I have a little line break, which is just like a bunch of equal signs. Then I add the task details and add all of these things. That's it, right? Now, I could have done this all in a single printer dot, but I broke it up because that's one of the beautiful parts about Rust is I love the way to interact with objects like this. So, all of these things, I print, and that's it. Nothing. There is a little feed and cut, and that basically calls the print command. So let's do this. Shall we do this on an MCP inspector, or do we want to do it in an actual client? Client. Okay, let's do it on client. So, I'm going to show you something. Let's do KRTK, all right. I'm going to pick any project I built, doesn't really matter. I have a little project here, and this is how I actually love to use this. I have a hard time finishing whatever I do. Like, if I don't have it on a note in front of me, and it's a small task, I usually just procrastinate and not do it. So what I was doing in the past, I would have sticky notes, I would just put them around my computer and just, oh, I need to do that, I do it, scrunch it up and throw it away. Then I discovered a receipt printer. And I'm gonna use my receipt printer to do my stuff. And I had like a little application that would print little to-dos, but then I built a to-do server, and that to-do server would be able to print stuff. Now, months later, I have an MCP server to do this. So what I'm gonna do here is I'm gonna show you, well, let's do this. Q agent Ferris. I'm gonna open up, I'm using Kiro here as my coding assistant. As you can see here, the thermal paper dreams is my MCP. It has loaded, and I'm gonna go ahead and I'm gonna get all of the to-dos. Well, actually, no, let me show you first of all. I can do agent, let's see, can I edit? I just wanna show you the MCP, Ferris. I wanna just show you the MCP configuration, that's it. There's nothing to it. I'm just pointing it to the binary. Now, I haven't installed this binary in my path, so I'm just giving it a path where the actual target compiled application is, and I'm passing 2 environment variables. The user ID, printer IP, and the printer port. And that's it. There's nothing to it. This is it. That's how you configure it. There's no MPX, there's no pipx, there's no cargo install. It's literally pointing to a binary on my machine. If it was in the path, I could just add thermal paper dreams, and it would be fine. So, if I tell it, get me all my to-dos. It's gonna think for a second, like that. It asked me, can I do it? There you go. It has run the command get all to-dos, and has got a bunch of different things here, right? I have a bunch of different example tasks, doesn't really matter, but there you go. All of these things. If you can see the last one, MCP with Rust, that's the one we created using the MCP inspector because again, the API server is not part of the MCP, so it was still stored there. But what I like to do here is look at my, I don't know, let's see, get links lambda and give me 2 tasks that I need to do to improve it, create to-dos for them, and print them out. In this directory where my current coding assistant sits, I have a bunch of Lambda functions, doesn't really matter, but some Lambda functions I built something before, so I pointed it at one specific Lambda function, look at it, tell me what I need to do to fix my code there, create some to-dos, and print them out. It's gonna go and list them, it's gonna go there to get links Lambda function, it's gonna read some of the code. By the way, I write Lambda functions in Rust, and so should you, because it's the best language to write stuff in it. Okay, first one, remove hard-coded domain and get links Lambda. Okay, cool, excellent, that's a good to-do, I like that. The second one, what is the second one? Add proper error handling for 30-day JSON, sure, bro. Okay? And now, it's printing. Wait a second, I'm gonna get close so we can hear the little printer noises. Let's do it. There we go. Look at that. I have stuff to do. Basically, it was able to do those things. Now, would you do this? Of course you would. It's cool. It's fun. I mean, you know, imagine having your team and you just kind of send them to-dos and on their table just print them out. Oh yeah, like Asana who? What? No more Jira tasks, no more GitHub issues. It's just paper. Of course, there's better uses for an MCP server, but with the power of Rust and with the power of such a fast, safe, structured language, I don't see any reason for you to write MCP servers in anything besides it. Because if you look what an MCP server does, it usually fetches data, stores data, prints a thing on a printer, or whatever else. And all of those things, Rust is perfectly capable of doing. And I would say it's better at doing that than other languages are. So, I promised I'm gonna share some code. So I can do, where's my code? There. First bit of Rust MCP. This is something I mentioned. That is the IAM policy autopilot MCP. It's an open source MCP server we built, we as in AWS. It's all built in Rust. So that one has both stdio, but also HTTPS. So if you want to see how it's implemented with remote capabilities, that is the thing to go. It's a little bit of a more complicated repository because it contains both the MCP server itself, but also the CLI tool, because in essence, this is just an MCP server that wraps a CLI tool. So you don't have to use the MCP server. There's a wonderful Rust CLI tool underneath. And if you want to see an example of code that I've showed before without the printer part, I built that Grimoire MCP server for my code patterns. This is something I use to store neat, interesting code patterns so I can reference them later on. This one is built exactly the same as I built and as I showed you the code today. So feel free to check it out. I will be sharing the little printer to do MCP server codes later in the week. So if you are not, well, if you're not following me on any of the socials or whatever, please do so. I will be sharing them online. Would love for you to see it. Without further ado, my friends. Oh, Darko. Darko Mesa. Well, actually, you know what? Crap. I don't have anything on my slide deck, but let's do it. LinkedIn is the easiest way because LinkedIn is where the business happens. You can find me there, I guess. Search my name. Oops. There. No. What? I promise I do this for work. There you go. You can find me, Darko Mesaros, on LinkedIn. Pretty uncommon name, I guess. You can find me, connect with me. I will be sharing all of these things. I share a bunch of content like this also on my personal blog, which is called rup12.net. You can find out stuff. I do a bunch of Rust content there as well. Actually, in an hour, the gentleman that's sitting just in front of me, AJ, and I are doing a Rust talk about why AWS is the best place for Rust. So it's happening here in the little silent disco area. Content Hub, that's the place. So if you want to learn more, we're doing it literally in an hour. With that being said, thank you all.